Okay, there are two types of frames of reference. One is an eternal frame of reference and one is an accelerated frame of reference. So what does it mean to be in an inertial frame of reference? That basically means you are standing still or you are at constant velocity. Okay, it's one of the two. And in physics, basically that's the same thing. Standing still and going at the constant velocity is the same exact thing. Now, how do you test to know if you're in an inertial frame? You hold a ball in your hand and you let go of the ball without pushing or throwing the ball. And if there's no external forces applied to the ball, like you hitting it, the ball will just float there and not move relative to you. So if the ball just floats there, you can't be hitting the ball or smacking the ball. That's what I mean by external forces. The ball will float there and not move relative to you. That's the test. If you want to test for an accelerated frame, what does that mean if you're in an accelerated frame? That means you're not at a constant velocity. You're accelerating in some way. So how do you test for it? Same test. Hold a ball in your hand and let go of the ball without pushing or throwing on the ball. And if there are no external forces applied to the ball, meaning you're not going to smack the ball after you hit it, after you let go of it, then the ball will move relative to you. Okay? So, let's say you're in outer space, like this man right here, and you're moving at 1,000 miles per hour, constant velocity, same speed the whole time. You can consider yourself standing still or you consider yourself moving. Either way, you're at constant velocity. Now, what would happen if he let go of this ball right here? If he held that ball out and let it go, since the ship, him, and the ball were all moving at 1,000 miles per hour, right? When he lets go of the ball, the ball's still going to keep going 1,000 miles per hour. He's going to keep going 1,000 miles per hour. The ship's going to keep going 1,000 miles per hour. So the ball ends up just floating there, right? Even though it's moving at 1,000 miles per hour, because it was moving at 1,000 miles an hour beforehand. And if you don't smack the ball, it's just going to float there. And that's how you know you're in an inertial frame. Just like in the space station, right? When the space guy in the space station lets go of the ball, what happens? The ball just floats there. Why? Because he is in free fall. And free fall is an inertial frame. And that's the test. That's how you test. That's how you know. See, there's a rule. All physics experiments will get the same result in every inertial frame. So no matter what inertial frame you're in, it doesn't matter what physics experiment you'll get, they all come out with the same results. And we know for a fact, when you're in outer space and you let go of a ball, it will just float there if you're going at a constant velocity. And what happens if you're accelerating at 9.8 meters per second squared? That's the same acceleration as gravity for Earth. What would happen if your spaceship, that means every second your speed increases by 9.8 meters per second. The next second another 9.8 meters per second, and so on and so on. It keeps just accelerating more and more. So what happens? The ship moves forward, right? It was at constant velocity, so everyone's moving at 1,000 miles per hour. But now all of a sudden, every second, the ship increases 9.8 meters per second its speed. The ship is going to move faster than the people that are still moving at 1,000 miles per hour, but once they hit the ground, once the ship runs into them, it's just like gravity. Acceleration and gravity are the same exact thing. Literally. So when the ship accelerates, it's in an accelerated frame of reference. When the ship is at constant velocity, or just standing still, then it is in an inertial frame of reference. And that's how you test. You can see the difference, right? In the accelerated frame, everything drops to the ground. In the inertial frame, everything floats. I don't think people realize that velocity and speed are not the same thing. Speed is distance per time, okay? But velocity is a vector. And as a vector, it not only includes distance per time, which is speed, but it also has direction. Okay, so if you change the direction, you change your velocity. Even if you're going 50 miles an hour, if you make a right-hand turn, you change your velocity. Even if you stay 50 miles an hour the whole time you're making your turn, and it doesn't matter, because your velocity includes direction, and you changed your direction, so you changed your velocity. Okay. I want you to think about this guy here. He's in a box. And he's got a metal rod here, and it's spinning. This metal rod, right? Now, if he's in outer space, you know, he'd be floating. But once he started spinning, right? Once he goes from an inertial frame to an accelerated frame and starts spinning, everything will fall to the ground, right? The ground will accelerate upwards. You know, it'll want to come out as it spins. It'll want to come out as a tangent in a straight line. You know what I mean? Tangent, straight line, tangent, straight line. But it can't, because there's a force from the bottom of the, this box that's pushing him this way. So he is accelerated this way. His speed remains constant, but his velocity, there's an acceleration. It's angular momentum is a form of acceleration, okay? So, is the Earth inertial? Earth isn't accelerated. Either way, it doesn't matter. Whether you disregard the orbiting of the sun or not, it's accelerated frame of reference. The Earth spins and orbits the sun, so it does have angular momentum. And so because of that, it is an accelerated frame of reference. But even if we disregard that, because most experiments won't show that spin or that angular momentum, that acceleration. So if we disregard that, the Earth is still an accelerated frame of reference, because when you hold a ball out, you do the test, you let go of the ball, but you don't push on it or throw it or anything, the ball falls to the ground. That proves you are in an accelerated frame of reference, okay? Now what happens if you're in a free fall, and you're inside of an elevator, let's say? Let's say you're that guy right there, and you're in the elevator, and you fall. You both will float. If he's holding a ball and he lets go of it, you can imagine falling in an elevator, how you would be weightless, right? And you might think that you are falling, but the whole thing is you are not falling. Space-time itself is what's falling. And it's not really falling, it's just curving or accelerating towards the ground, okay? But the space-time that is around this elevator, that is what's moving, and you are just staying along with that space-time. You're staying in the same exact space-time when you're in free fall. What is falling is space-time. You are just staying in space-time. You are staying in the same exact space coordinates. You are just traveling through time, and space-time is curved, and so you follow that geodesic. That's all. But you are free falling is inertial, and you know it by holding a ball out. The ball floats. Therefore, free fall is inertial, and Earth is non-inertial, or you could say Earth is an accelerated frame of reference. Even if you disregard angular momentum or angular acceleration, it is still an accelerated frame of reference on Earth. Okay, because the Earth accelerates up. Things don't fall down. Okay, Earth accelerates up. Right? I'll go into that in the next video. Now, if you don't believe what I'm saying, I gave 3 rules. I gave the rule about how you test for an accelerated frame of reference, how you test for an inertial frame of reference, and that all physics experiments are the same. Will have the same results no matter what inertial frame you are in. You will always get the same results. If you don't believe what I'm saying, that Earth is an accelerated frame of reference, even when you disregard angular momentum and orbiting, then tell me which of those 3 rules do you not believe in? Because you can obviously see if you hold a ball out on Earth, it will not float. Therefore, it's an accelerated frame of reference. What is your test? I'm giving you all this information. What is your test on how you know if you're in an inertial frame or you're in an accelerated frame? I gave you mine. Don't just tell me I'm wrong. Tell me why. Tell me what is your test. If you can't tell me what your test is, then you don't know enough about the subject to even be talking to me about it, really. I mean, to be telling me that I'm wrong, I mean. To talk to me, yeah, you can ask me any questions you want. Always remember, science is great.